Hello, I'm Louise Burney. I'm one of the research assistants at the Applied Sports Technology, Exercise and Medicine Research Centre. I'm working on a Smart Expertise project which is funded by the Welsh Government and the European Regional Development Fund. My specific project, AFM2, aims to develop new products which use advanced printing techniques and functionalised nanocarbons such as graphene. This is a joint project with the Welsh Centre of Printing and Coating with several industrial partners. So the first product that is going through the pipeline is the printed heated garment for the English Institute of Sport. So muscle temperature post warm-up has been shown to have a major impact on performance in sport. So research done by Professor Liam Kilduff at Swansea University has demonstrated the performance benefits of passive heat maintenance, such as using blizzard jackets or blankets, as in the photos. This has been extended to active heating, so you may have seen at the last 2 Olympic Games the track cyclists using the heated Adidas trousers to maintain muscle temperature post warm-up. However, this technology has several limitations. It's based on a wire bent throughout the garment, and every time you bend the wire you get a localised hotspot which limits the overall power and therefore operating temperature of the garment. Also, they're typically only outerwear, so jackets over trousers. So at Swansea University, we have developed a printed heated garment using graphene-enabled inks. And this has several advantages over the wired products. It can provide a uniform heat distribution across the panel. It can be adhered directly to the garment, meaning a closer fit and more effective heat transfer. The panels are lightweight, thin and flexible, and they have a rapid response to change in voltage, so rapid change in temperature, and also incorporate intelligent temperature feedback. Several versions of these garments have been developed for the Tokyo Olympic Games, working with the industrial partners, Haydale, the ink manufacturers, Screen Tech, the printers, and the performance innovation team at the English Institute of Sport. So part of my role is also to scope other potential applications for the printed heated technology in sport and healthcare. To do this, I've been working with the English Institute of Sport, Sport Wales, and Swansea Bay University Health Board. One of these potential applications is using the heated garments to treat cold intolerance in patients with severe peripheral nerve injuries to help them manage their pain levels. The second product going through the pipeline is a printed piezo-resistive pressure sensor, which has been developed by engineers at the Welsh Centre of Printing and Coating. The sensors work by they change electrical resistance in response to applied pressure. The graph on the screen shows the relationship between the resistance, the measured resistance, and the applied force. Again, I'm looking at scoping potential applications of this technology in sport and healthcare. Our pressure sensors have several advantages. They are thin and flexible, and they can be printed to any size, shape and sensor density. Also, you can tune the pressure range by the number of layers that you print. So potential applications of this technology include measuring pressures at any athlete equipment interfaces such as foot, wheelchair pressures, bike saddle pressures. I've also been working with Swansea Bay University Health Board on potential applications such as measuring diabetic but also pressures. So that's a brief summary of my research. If you've got any questions or would like to get in touch, we have an email address which is smartsport@swansea.ac.uk. Thank you.